How the Lockheed SR-71 Blackbird Works, a complete guide. The Lockheed SR-71 Blackbird is one of the most iconic aircraft in aviation history, renowned for its unparalleled speed, stealth capabilities, and cutting-edge technology. Developed in the 1960s by the United States, this reconnaissance aircraft was a key player during the Cold War, capable of flying faster and higher than any other operational aircraft of its time. This article provides a comprehensive look into the engineering marvel that is the SR-71 Blackbird, exploring its design, propulsion, stealth capabilities, and operational use. The development and purpose of the SR-71 Blackbird. Background and origin. The SR-71 Blackbird was developed in the 1960s by Lockheed's Skunk Works division, led by the legendary aerospace engineer Clarence Kelly Johnson. The aircraft was conceived during the Cold War to address a critical need for a high-speed, high-altitude reconnaissance aircraft that could evade Soviet air defenses. The aim was to create an aircraft that could operate beyond the reach of enemy fighters and surface-to-air missiles, SAMs. The SR-71 was the successor to the U-2 spy plane, which had been effective but vulnerable to enemy action, as demonstrated by the 1960 incident when a U-2 was shot down over the Soviet Union. The SR-71 was designed to overcome these limitations with extreme speed, Mach 3+, and altitude, 85,000 feet or higher, allowing it to outrun threats. Key objectives and design goals. The primary mission of the SR-71 was strategic reconnaissance, providing the U.S. military and intelligence community with critical information on enemy activities, particularly in hostile or denied airspace. The design objectives for the SR-71 were to achieve speeds exceeding Mach 3, 3 times the speed of sound, operate at altitudes above 80,000 feet beyond the reach of most air defenses, minimize radar cross-section to reduce detection risk, be capable of long-range missions without the need for aerial refueling. Engineering and design of the SR-71 Blackbird. Airframe and materials. The SR-71's design was revolutionary, with a sleek, elongated fuselage and distinctive chined forward section, which contributed to its aerodynamic efficiency. The aircraft's airframe was primarily constructed from titanium alloy, a material chosen for its strength and ability to withstand the intense heat generated by sustained supersonic flight. Approximately 93% of the SR-71's structure was titanium, which posed unique manufacturing challenges, as titanium is notoriously difficult to machine and work with. This required innovative techniques and tools, many of which had to be developed specifically for the SR-71 program. Aerodynamics and flight characteristics. The SR-71 featured a unique aerodynamic design optimized for high-speed, high-altitude flight. Key features included delta wings. The SR-71 had delta-shaped wings, which provided stability and lift at supersonic speeds while reducing drag. Chinese, the forward fuselage incorporated. Chinese, long, narrow surfaces extending forward from the wings, which helped stabilize the aircraft at high speeds and enhance lift, especially at lower speeds during takeoff and landing. Shock inlet spikes. The engine nacelles featured movable spikes that controlled the airflow into the engines, crucial for maintaining supersonic speeds efficiently. These spikes would move forward and backward based on the aircraft's speed to optimize performance. Propulsion system, Pratt & Whitney J58 engines. The SR-71 was powered by 2 Pratt & Whitney J58 engines, each capable of producing 32,500 pounds of thrust. These engines were a hybrid between a conventional jet engine and a ramjet, operating as turbojets up to Mach 2 and transitioning to ramjet-like operation beyond Mach 3. Key features of the J58 engines include variable geometry, inlets. These inlets could adjust to slow down the supersonic airflow entering the engines to subsonic speeds, which was necessary for efficient engine operation. Afterburners. The engines were equipped with afterburners that injected fuel directly into the exhaust stream, dramatically increasing thrust for supersonic flight. bleed bypass system, a unique bypass system that allowed excess air to bypass the engine core, reducing drag and enhancing efficiency at high speeds. Fuel and cooling systems. The SR-71 used a specially formulated fuel known as JP7, designed to withstand the high temperatures experienced at Mach 3+ speeds. The aircraft's skin could reach temperatures up to 600 degrees (316 degrees) due to air friction, necessitating the use of JP7, which had a high flash point and low volatility. Additionally, the SR-71 used its fuel as a heat sink. Fuel would circulate through the aircraft's skin and engines, absorbing heat and helping to cool critical components. This innovative cooling method was crucial for maintaining the structural integrity of the aircraft and preventing overheating. Stealth and survivability features. Low radar cross-section (RCS). One of the SR-71's critical design considerations was minimizing its radar cross-section (RCS) to reduce detectability by enemy radar systems. Although not a true stealth aircraft by modern standards, several design elements contributed to lowering the SR-71's RCS. Angular surfaces. The aircraft surfaces were designed to reflect radar waves away from the source rather than back, reducing its radar signature. Composite materials. Radar absorbent materials, RAM, were used in some parts of the aircraft to further reduce radar reflections. Defensive systems. While the SR-71 relied primarily on its speed and altitude for defense, it was also equipped with electronic countermeasures, ECM, to jam enemy radar and evade missiles. The aircraft's defensive suite included radar warning receivers, RWRs, chaff and flare dispensers, and electronic jammers to disrupt tracking and targeting systems. Operational use and missions. Reconnaissance missions. The SR-71 was primarily used for strategic reconnaissance missions, gathering intelligence on enemy forces, military installations, and missile sites. Equipped with advanced cameras, side-looking airborne radar, SLR, and electronic intelligence, ELINT sensors, the SR-71 could photograph and map large areas with unprecedented clarity and detail. Flight operations and mission profiles. Typical SR-71 missions involved rapid climbs to cruising altitudes above 80,000 feet, followed by high-speed runs over or near target areas. The aircraft's speed and altitude allowed it to penetrate hostile airspace, collect intelligence, and exit before enemy defenses could react effectively. A notable operational highlight includes the SR-71's missions over North Vietnam during the Vietnam War and flights over the Middle East, Soviet Union borders, and other sensitive regions. The SR-71's ability to fly at Mach 3+ meant that it could often complete missions in a fraction of the time required by other reconnaissance aircraft, minimizing its exposure to threats. Strategic impact and achievements. The SR-71's intelligence-gathering capabilities were invaluable during the Cold War. It played a key role in monitoring Soviet missile tests, tracking military buildups, and verifying compliance with arms control agreements. Its speed and altitude also meant it was never shot down in over 3,500 reconnaissance missions, cementing its reputation as a near-invulnerable spy plane. Conclusion: the Lockheed SR-71 Blackbird was a triumph of aviation engineering, setting speed and altitude records that remain unbroken to this day. Its blend of advanced materials, powerful engines, and innovative design made it a unique and formidable aircraft that served the United States for over 3 decades. While the SR-71 may no longer grace the skies, its legacy lives on, inspiring future generations of engineers, pilots, and aviation enthusiasts to push the boundaries of what is possible. The SR-71 Blackbird remains a testament to human ingenuity and a reminder of a time when speed, stealth, and technological innovation were paramount in maintaining global security during one of the most tense periods of modern history.